So, what is this? Year 11 math. 2020. I included the S, so you're too proud. It's my favorite color. All right, ratio. No, there's no reason you should be bad at this. Ratio is, guys, come on. Ratio is one of the things that is one of the easiest things to do in mathematics if you let it be. But you have to understand it. So today what we're going to do, all we're going to do is introduce what a ratio is and talk about simplifying a ratio and the forms that are the format of a ratio. Okay? So, a ratio is simply a comparison. I love ratios. So, when you are driving down the street and you're looking at the speedometer, it measures the speed in what? Kilometers per hour, right? Well, that's a ratio. Oh, you also put km, right? Kilometers per hour. There you go. I'm not metric. Give me a break. I use miles. Okay. Well, it's all right. So let's just write it out then. Kilometers per hour. That's how many kilometers you travel in what? 1 hour, right? And we know that this is a ratio because of that little magic word. Per. Can anybody give me another ratio that we use a lot? Another car one. Fuel? Yeah, miles. Or not miles. Kilometers per liter. I'm mixing it up. Kilometers per liter is the fuel ratio, right? Okay. There are tons of other ratios that you could use too. But again, the magic word is the word per.
Wait, does this apply to like... Oh, no.
All right. So, and per, the word per can have several different... I'm going to use a little funny arrow because the word per, it just says per, and you just get rid of that part. Can have several different ways of writing it. Several different symbols for per, which per is a ratio, right? We could say kilometers per hour. So the fraction bar is another way of saying, if you see per, that's a way of translating it. Or it can be kilometers to hours. The colon is another way of writing a ratio. You'll see that written quite a lot as a ratio. Okay? And those are the main two. You can also be comparing several things, more than just two things, right? So, for example, I could have 3 to 4 to 5. This is a ratio. 3, 4, 5. Can anybody remember what 3, 4, 5 is? It's the ratio of the sides of a right triangle, right? The ratio of a right triangle is always 3 units to 4 units to 5 units. Remember that? From geometry? At some point you had geometry, never? Okay? So if you have a right triangle, this side's always 3, that one's 4, and that one's 5. Or some ratio of those numbers. So it could be 9, 12, and 15. Multiply them all by 3. But they always maintain the same ratio. Okay, that's not important. Who cares? But anyway, but notice I have 3 numbers. But it's still a ratio. How do I know it's a ratio? The colons. There you go. They're separated by the colons. Right? So we're going to talk a little bit about writing these. And the most important thing is how to simplify them, okay? Because there are a couple of rules for working with ratios. So, a ratio, different symbols, right? The first rule is that you must simplify it. Okay? This is very important. Simplify it. And to simplify it, there are a couple of things. First, okay, it can have no common factors. No common factors. Now, let's talk about that because you may not remember what a common factor is. That means no number that will divide evenly into every number in the ratio. Factor means something that will divide unevenly. Okay? So no number that will divide evenly into every number of the ratio. Now what if it divided into two of them but not the third one? Who cares, right? We're fine. But if it divides into all three, can you leave it? No. We have to divide it out. Okay? And so we'll talk about how to do that. To divide it out, okay, or to check, or divide.
Is this step 2?
Nope, I'm still in. This is A, talking about the common factors. No common factors. I like to use a process that uses upside down division. Now, don't freak out. Division, because we're dividing out common factors, we know we're going to have to use division, right? So upside down division really makes it easy to be able to do this and stay organized. So upside down division. You're not going to have many of these to simplify, and this division is usually fairly straightforward. So let's say we have 60, 36, 24. We know it's a ratio because they're separated by colons. Good. But is there something to divide into 60, 36, and 24? Yes. Now, some of you will find out and will know what it is immediately. Some of you might find to see that they'll all divide at least by 2 and think of that. Some of you see, well, they'll divide by 3. Some of you are going to know they'll all divide by 12, right? So we need to get you all to the same spot. And the easiest way to do that is by using this upside down division process. So here's what I'm going to do. Just put an upside down division symbol around them. Well, a division symbol indicates that you're going to do what operation you think? Divide, right? So here are the steps.
Wait, what's this upside down thing?
It's just an upside down division symbol, just because you're going to do division. And it's upside down because it keeps you focused, it keeps you organized. Just hold on a minute. Divide out any common factors until there are none left. The beauty of this process is that you don't have to get the biggest number right away. You can continue to divide over and over and over again until you make sure that there's nothing else that will divide into it. Because if you look at 60 and 36 and 24, what do most of you see will divide evenly into all of those pretty easily? 12. Oh, baloney, not 12. I told you 12. But some of you might do 12. But most of you are going to see 2. All right, that's good. That's beautiful. But most of you are going to see they're even. So they're going to all divide by 2, right? Do you agree? Yeah. So let's divide them by 2. 60 divided by 2 gives you what? 36 divided by 2 is?
18.
24 divided by 2 is? 12. Do you see anything that will divide into 30 and 18 and 12?
6.
Yeah, they'll all divide by 6, or they could divide by, you might see what?
3.
2 again, or 3. Really doesn't matter how fast you get there. Use the number you're actually seeing, not the one that somebody else says is, so you think it's right. I am very simple, so I see 2 again. Yes, I'm dragging you through a knothole, but just deal with it. I just want to show you that you don't have to use big numbers. You can always just use 2 until you can't use 2 anymore. Then try 3. Dividing by smaller numbers is easier than dividing by bigger numbers, isn't it? Okay, so let's divide. 15, 9, and what? 6. Is there anything that'll divide into 15, 9, and 6? They'll all divide by 3, right? So divide by 3, and you get 5, 3, and 2. Is there anything that'll divide into those? Nope. Then that's your answer right there. 5, 3, 2. Now again, I took you the furthest way you could possibly go by dividing by 2, then 2 again, then 3. But you don't have to. Well, let's see, our numbers were 60, 36, and 24, right? You might have looked at those and said, oh, those will divide by 3. So that gives you 20, 12, and 8. And then said, wait a minute, those all divide by 4, which gives you 5, and 3, and 2. Same answer? Got there a little faster because I used bigger numbers. Have to? Nope. So it doesn't matter what you use. You just continue to divide until you can't divide by anything else. Okay? Now, did some of you see they'd all divide by 12 right away? Sure. Good. Fine. Perfect. Divide them all by 12 and you're done. Right? 60, 36, 24. All of those will divide by 12, which gives you 5, 3, and 2. Right straight to the answer. But is it about speed or is it about accuracy? Accuracy. So if you know that you like to divide by 2s, and because if you divide by 2, you break it in half, right? You already made it half as small, so dividing by 2 still gets you there fast, just as fast. Maybe a little slower, but okay. How's that look? So you're going to practice a little bit of those with some of those, okay? Yeah, just one step. Just divide out stuff until you can't. Divide out common factors until you can't. Now, that was A, though. There's a B. A proper ratio can contain no fractions. A ratio can be a fraction, but if it's written in colons, you can't have fractions. Okay? So, what we're going to do is, to clear the fractions, because notice here, I made these numbers a lot smaller, didn't I? Than I originally started with. But because I did the same thing to all of them, they're still in the same ratio. I changed the numbers, changed the size of the numbers, but I didn't change their relationship to each other. Right? Because I did the same thing to all of them. Well, I can do the same thing with fractions. And you might remember this from when you worked on equations when you did algebra, when you did equations. To clear the fractions, first, find the least common denominator, or y'all call it lowest common denominator, I think. Okay? Least common denominator. And you can do this. You can do that by doing the same upside down division symbol. So the least common denominator simply means the smallest number that all the denominators will divide into. Now be careful. This isn't what divides into them. It's what they'll divide into. So it's got to be at least as big as the biggest number. Okay? And we'll look at some examples if you don't remember. That all denominators, D, capital D's for denominator, that all denominators will divide into. You can write out denominator if you don't like my abbreviation. But I never use capital D for anything other than denominator. Capital N is always numerator. Right? Okay. Then, second step, multiply every fraction by that LCD. Okay. Now, hopefully this is not new to you. You've added and subtracted some fractions before. That's where you use lowest common denominator.
Still don't know how to do it. Yeah.
Oh, okay. Well, I'm going to give you two options because you guys are calculator experts now too, right? So I'm going to give you two options. I'm going to show you how to do it with fractions, but we can usually, not always, but usually change fractions into what? Decimals. And then we can use the decimals because we're not allowed to use. We got to learn how to get rid of decimals too. So, but can you change every fraction into a decimal easily? Nope. So you've got to know the fraction method too. Okay. Now, when you're multiplying every fraction by the LCD, I want you to think about this. Divide, then multiply. This would be so much easier if I had taught you your whole lives, because then you'd know all these patterns. Mathematics is a series of patterns that we need to learn. And yes, we need to. You eventually want to get out of high school, right?
Yeah.
Right? Well then, yeah, that's why you need to know. Are you going to make little mathematicians out of all of you? No. Do we care? No. But do you want to pass high school? Yes. Yeah, you're in high school. Do you want to get out of school at some point? Okay. All right. Are we ready? Let's look at some so I can show you what I mean by it. Super, super easy, but you just have to make it, you just have to let it be. So say we have 2/3, okay, 1/6, and I don't care, 1/2. So this is our ratio. I know it's a ratio because they're separated by the colons. And I don't like this ratio though because there's something wrong with it. What's wrong with this ratio? It has fractions in it. So what I need to do is I need to get a common denominator. So what are my denominators?
3, 6, and 2.
3, 6, and 2, right? Well, to get a common denominator, it's got to be big. It's common factor. There's a common factor of. Well, there's not even a common factor.
Can it be the same as the biggest one?
Yes, and it usually is. Okay, so here's how to get a common denominator. To get the LCD, first find the biggest denominator. Which one's the biggest denominator? 6. Okay. Second, will the other denominators divide evenly into it? Just ask yourself, will the others divide evenly into it? Okay? I'm going to spell out denominator because y'all are awful. Denominator. Okay. All right. So, biggest denominator up there is a 6, right? Will 3 divide evenly into 6? Yes. Will 2 divide evenly into 6? Will 2 divide evenly into 6? Yes. So that means the LCD for 3, 2, and 6 is 6. That's the smallest thing they'll all divide into. Okay? Let's look at another one. Say we have 3, 9, and 12. Okay? Nah, let's not do that one. Let's do 3, 9, and 18. Okay, that'll. All right.
Yeah, I think it's good.
Nah, because 9 wouldn't divide into 12, so I was making. I'm trying to make it the easiest ones right now, and then we'll build. All right. What's my biggest denominator up there? 18. Will 3 divide evenly into 18? Yes. Will 9 divide evenly into 18? Yes. Then what's my LCD? 18. Okay. Now, do you think that's always going to work? Nope. Doesn't always work. Yep. Say we have 3, 9, and 12. What's my biggest denominator up there?
12.
Will 3 divide into 12?
Yes.
So we're good there. But will 9 divide into 12? No. So we can't use 12. So what we'll do is, if not, just make the biggest one bigger. Okay? By multiples. Hold on. Well, you frequently don't get the first what's brand new the first time you've seen it. This shouldn't be new though.
It is.
This is junior school stuff. Okay. So we're gonna. So multiples, guys. Multiples means multiply.
36.
Times 2. Then times what? 3. Then try what? 4. Then try 5. And you keep going until you get a number that it will divide into. So what's 12 times 2?
24. No.
3 divides into 24, but will 9 divide into 24? No, so it won't work. So what's 12 times 3?
36.
3 divides into 36. Will 9 divide into 36? Yes. So the LCD is 36. You're just making it bigger.
This is hard.
Bigger and bigger and bigger and bigger by multiplying. No, it's not hard. Okay? All right? Yeah, but that doesn't make me good at math. Okay? All right. Let's look at another one. Uh-huh. I'm terrible at math. Have you ever noticed I make y'all do all the math? I can tell you how. All right. It is, and you still have to pay me. I love it. Okay, Brett, here we go. Let's say we have 3, 4, and 5. Here's our ratio, 3, 4, and 5. Okay? So make it 1/3, 1/4, 1/5. Can I leave those fractions? Nope. Got to get rid of them by finding the LC what? D. Will 3 and 4 divide even into 5? No. So I've got to make 5 bigger. Okay? So 5 times 2 gives me 10. Will 3 and 4 divide into 10? Nope. 5 times 3 gives me 15. Will 3 and 4 divide into 15? No. 3 will though, won't it?
Yes.
So I'm good at 3, I'm okay with. Who cares? But it doesn't matter because if 4 doesn't work, then that doesn't work. So 5 times 4 is what?
20.
Will 3 divide into 20?
No.
4 will, but doesn't matter. They all have to, right? Okay, 5 times 5 is?
25.
Will they divide into that? Nope. 5 times 6 is?
30.
Will they divide into that? Nope. 5 times 7 is?
35.
Will they divide into that? Nope. 5 times 8 is?
40.
Will they divide into that? Nope. So sometimes you just have to keep going.
Is there a faster way?
Just kind of assume what it could
Yeah.
Take a wild guess.
Now, no. The reason this is happening, it's going to end up being 5 times 12.
Yes.
Was 12? Was 3 times 4?
Right. Because
Multiply
3,
those two.
3, 4, and 5 don't have anything in common, do they? So that means that you end up just multiplying them together.
And
But
then you multiply. Oh.
be careful, though. You don't want to do that if the numbers are too big. You don't want to use that shortcut always. In this case, we had to do it because they didn't have anything in common. But here, 3 and 6 and 2, 3 would divide into 6 already, wouldn't it? And 2 divided into 6 already. So we were able to use smaller numbers. But if you can, I hate to say this, you can just multiply them all together and get the number. Sometimes though we'll give you a huge number. So like here, if we did that here, 3 times 6 times 2 would have given us 36. That's way bigger than 6, isn't it?
Yeah, that's 6 times.
Right? But it might be easier for you to remember. It'll divide out. So you could do it, but it's a bad idea.
So how do you recognize weak
When they have nothing in common. Right? If they have nothing in common, then you're always just going to have to multiply them together. Okay? But you have your calculators. So is a big number really going to be a big problem for you? Would you rather just multiply them together all the time? Because I can let you do that because it doesn't really matter. They'll divide away in a minute. Okay? So, on your cheat sheet, if you want to get LCD, just multiply the denominators together if you want to. It's not really the LCD, it's just, but it'll work. It makes me a little crazy, but I can't see a reason why. Hold on just a second though. I can't see a reason why you can't use that shortcut because you have a calculator. You're just going to get huge numbers sometimes, right? And that freaks y'all out too sometimes. But if the method is hard, if learning the method is harder than working with the big numbers, work with the big numbers. So just multiply them together, okay? I don't like that, but that's all right. If it makes your lives easier. Then what you're going to do, once you find the LCD, remember, that was just that step, okay, to get the LCD. Okay? We're going to multiply every fraction by that LCD. Right? Remember, we already put that in your notes. Using this pattern, divide then multiply. Okay? All right, so let's just go to ones we did. So here we go. Here we have our fractions, guys. Y'all are phasing out on me here. All right. So our fractions are 2/3, 1/6, and 1/2. And we need to multiply each one of them by what was my LCD in that case? 6. Sorry, stop recording. So 6 times 2/3, 6 times 1/6, 6 times 1/2. And it's fine that I'm multiplying them by something because I'm keeping it in proportion or keeping the ratio true because I'm multiplying them all by the what? Same thing. Okay? So 6 times 2/3. Do you remember how to multiply a whole number times a fraction? You could turn it into a fraction, but won't 6 divide by 3?
Yes.
6 divided by 3, and what you get left times 2. Divide by the bottom, multiply what's left times the top. So 6 divided by 3 is 2 times 2 is done. Fraction's gone. Okay? Divide. Let me get some room to write here. Hold on. Divide the LCD by the denominator. Multiply that times the numerator. And the fraction's gone. Because if you'll remember, when you're multiplying with fractions, 6, if you change it, 6/1 times 2/3. If you multiply it straight across, you get 12 divided by 3. And what's 12 divided by 3?
Is that the fourth? Is it not 4? The one at the top?
This just goes under that divide then multiply thing. So it's really not the fourth step. It's just that you don't divide and multiply. Okay? So, you've got 2 choices again. Would you rather do it efficiently or easier? 6 divided by what? Is 2, and 2 times 2 is 4.
Don't you do 6 divided by 2 and then times them by 1? Yeah. Because you do, so 6 divided by...
Yes, 6 divided by 2 is 3, and 3 times 1. Or you can just multiply them straight across because you've got calculators.
No,
It's fine. You're making me crazy. 6 times 2/3. 6 times 2 is 12. 1 times 3 is 3. And 12 divided by 3 is 4. Does that make your life easier?
Wait, honestly, I kind of liked it.
So you do the whole LCD.
Then pick one. Pick the one you like. Okay? I'll show you both. All right. So let's do the next one, guys. First, let's do it using the pattern. 6 divided by the denominator. So 6 divided by 6 is a
1.
And 1 times 1 is
2.
Okay, I'm going to go become a garbage man. I'll see y'all in a bit. I'll see you around in front of your houses. All right, 6 divided by 6 is what?
1.
And 1 times 1 is 1. There we go. All right. Y'all crack me up. All right. So let's do it the other way though. If it's 6 over 1 times 1 over 6, that's 6 times 1 is 6. 1 times 6 is 6, and 6 divided by 6 is 1. Either way, you pick the way you like. Okay? Because they both work, right? Let's do this last one. 6 divided by 2 is 3, and 3 times 1 is 3. Or the other way. Hold on. 6 over 1 times 1 over 2 is 6 over 2, which is 3. Same thing. Right. No, you're done. So your answers, your ratio is 4, 1, 3.
But how's the first one 4 when 2?
6 divided by 3 is times 2 is, that's how it's 4. Divide by the bottom, multiply what's left times the top.
Oh, okay.
Because the 6 doesn't exist anymore. 6 divided by 3 turned into a what? And 2 times 2 is? The 6 doesn't exist after you divide it, right? No, 6 divided by 6 turned into a 1.
Wait, is the lowest denominator?
Divide first and then multiply times the top. Or just multiply straight across and then you can do it the other way.
This example.
Practice. All right. Let's look at another one, guys. Here we go. All right. Hold on. So let's say we have 1/3, 1/4, 1/12.
Can you just...
I haven't said anything. We need to get our LCD. So look at the biggest one. The biggest one is 12. Will 3 and 4 divide into 12?
Yes.
So the LCD is 12, yeah? That's all we have to do. So if the smaller ones divide into the bigger one, then we're done. So now we have to multiply, though, each one of those by 12
Wait, why? By 3.
to eliminate the fraction. Multiplying by the common denominator is what eliminates the fractions.
First one is 4.
Okay? You bet. 12 divided by what? 3 is 4, and 4 times 1 is...
By 3 equals 4, yes.
And 4 times 1 is 4.
4 times
12 divided by 4 is
3.
3 times 1 is
3.
3. 12 divided by 12 is...
1.
And 1 times 1 is...
1.
And there's your ratio.
Wow, the same numbers, just in a different order. Crazy.
Yes?
So in like the test where it says find the lowest common denominator, you wouldn't have to sorry, you wouldn't have to put the 4, 3, 1 in there.
You just have to
put the 12.
Right. But but you're never going to do that in this particular exam. You're never going to do that except unless you're doing simplifying a ratio. Okay? Okay? All right.
Yay! So this is if the fraction. This is if the fraction
Right.
is the equation.
Guys, what if I have this?
Oh my gosh, are you serious? Oh, wait,
4 times 1 plus 3. Take the denominator times the whole number and add the numerator. So 4 times 1 is
4.
plus 3 is
7.
and put it back over the original denominator.
You want to keep it as a fraction?
Element. So yeah, we need to turn it into a fraction instead of a mixed numeral.
Oh, I see.
So what do we have? 2 and 1/3. What do I do? 3 times 2 is?
6.
And then add what?
1.
So
Wait, what are the dots around the 4? So 7 over 3.
It's still 7.
what? A dot means multiply. Sorry, I forgot. Y'all don't like the dots.
No, I'm talking about like underneath the big one.
Oh, that was me just pointing and it made dots. Sorry. Okay. 3 times 2 is 6 plus 1 is 7 over what?
3.
3. Okay?
Okay.
Remember that part?
Hold your
Okay.
phone.
Okay.
You don't change
Will
the
we come
denominator.
back to that next lesson?
Well, hopefully you've done some so you'll be okay with it because you'll be good. Come on.
Hey.
All right. Bell's about to ring, so I've got to do decimals really quickly. Hold on. It's easy to clear decimals. Well, because you can't clear the fractions unless they are fractions. They can't be mixed numerals. Right? So before you can eliminate the fractions, you have to change them to this. Okay? To clear decimals, simply move the decimal. Okay? But all the same number of places. So, if you have 1 decimal place, 2 decimal places, and 3 decimal places, which one do you think you're going to have to use?
3.
The biggest, the one with the most decimal places. And you're going to have to move how many of the decimals 3 places? All of them. Right? Now, let me show you what that looks like. 0.5, 0.15. This is why you can change fractions into decimals and make your life easier too. Which one of those has the most decimal places in it?
0.15.
It has how many?
3.
2. 2 decimal places, right? 0 doesn't count. So all move 2 places. Now we're trying to get rid of the decimal, so is it going to move right or left? Yeah, be careful. It's got to move to the right to go away. So this one's going to move 2 places to the right, which is going to turn it into a what? 50. This one's going to move 2 places to the right, which is going to turn it into a 15. This one's going to move 2 places to the right, which is going to turn it into a 20. And now you can divide them all by 5. There you go.
I'm done. I'm leaving my classes.
I feel like if you moved it to the left, it has the same effect.
Yeah, that's what I was
If you move into the left, no, you get...
divide by 5.
No, you don't. If you have 0.5 and you move it 2 places to the left, now you have 0.005.
Right.
That ain't right.
If you move it this way, it becomes 50.
And you move it that way.
What about 5? You move it that
Yeah, that's what I was thinking.
Yeah.
You move it that
That's
way.
a place illustration doesn't exist. It's 0.5. If you move 2 to the left, it becomes 50.
Becomes 0. No, it doesn't. It becomes... If you move it 2 places...
I get the same answer as you. I get the same answer as you.
Okay. Page 48 and 49. Just that one section. Ratios. Simplifying ratios. Page 48. Give it a shot.